itinerary returned by the search algorithm is the flight path contiguous? In other words, does it go from A to B, and then from B to C, and then from C to D, rather than A to B and then C to D with no connection between? Is that a proof that it's working? If it satisfies this property of being contiguous, is it working properly? Not necessarily, but at least it rules out certain broad cases. It's a sanity check, as we often talk about it. So we talk about assertions as sanity checks. Is this result at least sane in the sense that you can look at it and it passes the red face test? It looks like it's reasonable off the cuff. And you can often check a few high-level properties and quickly come to confidence that it's not some random result. It's not obviously hugely broken. And we're going to come back to this principle in our discussion of smoke tests a bit later today. Okay? Assertions. Very valuable, and I'd like to see them in your code as soon as possible. Now, I wanted to talk a little bit more about this issue of accountable positions for this class. I had alluded to this earlier on the very first day about the sorts of positions I want to see, but I want to expand on those a little bit to make sure that you have a sense of what's expected of you, and for those stepping into more serious roles in this regard, things like project manager, build master, development lead, give some sense as to what sort of tasks you're expected to take on. This issue of accountable positions is about accountability. It's about somebody taking charge of making sure that things get done, certain types of things get done. And a lack of accountability increases the risk that things will fall through the cracks. So what am I looking for here? I'm looking for a defined project manager. This, like all the other aspects of this class, is not about, playing pretend games and appointing this for the sake of appointing it. It's because this role is so critical in a lot of the functions of these projects. This project manager will often be less involved in the technical side of projects. They're very busy, and this is the key word for them, facilitating things. Their job is to make sure that the team can get its work done in as best a way as possible, as smooth a way as possible. They are looking for potential conflicts between team members or cases where communication is not occurring in the team. So they're facilitating the work of the others. This was a new concept to me. 20 years ago, I stood behind you. I would have stood in front of you wearing a younger man's shoes and like yourselves, full of a lot of training but not a lot of real-world experience. And within this context, I was working in a small startup that we had created doing software work for contracts, larger scale contracts, typically about a couple $100,000 each, for educational institutions around the U.S. And we had a CEO who had been an executive at IBM and was working with us. We were a small shop, about 5 people. And I was struck by the fact that as a former executive, he spent a lot of his day trying to remove barriers from the people in the team, trying to find out where are your sore spots, what's troubling you right now, what single thing could I do that would help you be more efficient or more effective in your work. And that's a lot of what a project manager does. They also help people coordinate effectively, schedule meetings, for example. They're the ones who are often highly involved in triage, deciding, okay, is the project good enough yet? What bugs do we got to fix? What do we not know about the situation with the project and that we need to know within the next few days so that we can decide whether we're ready to freeze the code base? Often they'll handle the management or user interfaces, the interface to the stakeholders, help coordinate meetings there, help make sure that the team is in sync with the stakeholders, and often driving peer reviews as well. So this project manager is not a kind of czar who's in charge of every bit of the code base and is has tight-fisted, control over every technical detail of the project. If that's what you're looking for, you're not going to find it in a project manager position. Project manager is the person I'm going to write to as sort of with confidence that if I write to them, they can spread the knowledge to the group. It's the person who will be dealing with the stakeholder within the team, and it's often a person who has quite good people skills. A couple years back, we had a great team full of promise doing a database, an STI database. In the software area, does anyone know what STIs are? Well, okay. Okay. So this is actually, in this case, in software, it's system trouble incidents. But in fact, lo and behold, funny you mention it, they were building a database of sexually transmitted infections. So they were. No, it wasn't showing where they are on the map or something like that. No, they were doing it for a researcher on campus over at this organization called VITO in Intervac. It's across campus, and it's a big international center that's known for their work in infectious diseases. And they had a bunch of data on chlamydia, which is a prominent bacterially transmitted sexually disease. And little did you folks know, funny facts you learn in this class. Have you ever seen that sign outside of Saskatoon when you come into the city? It says Saskatoon shines. Well, I found out from the chief medical health officer of our health region that Saskatoon is actually, of the provincial cities, at the time it was the #1 city in terms of percent of gonorrhea prevalence. So it had the highest rates of gonorrhea anywhere among provincial cities in Canada. So I told this to another colleague, and he said, man, instead of saying Saskatoon shines, it should say Saskatoon claps. Because it's also called the clap. In any case, this team was working on this, and they had a project manager. Coming to the point of this, they had a project manager who was very, very good technically, top of his class technically, but his people skills in terms of reading things weren't really where they needed to be for a project manager position. And in retrospect, in their postmortem, they said probably this guy wasn't the best person for the job. It sounds glamorous, but a lot of the work is very prosaic work to make sure that the project gets its work done by the end of the semester, on time. And so if you're looking for glamour, and if you think that this is your the indication that you're a king of the hill in terms of technical expertise, don't go here. It's not. It's a position that is absolutely probably the single most central position to project success, but it is not about you're constantly in code. I think he would have loved to have been in the code in retrospect. He would have loved to have been the one who's probably a developer lead driving forward the development. So design or development lead for the project would be someone on the technical side who has the vision of sort of, okay, how are we going to do this? They're thinking about all the different technical, the technologies that need to be brought to bear, the possible technologies that could be used, and trying to decide, how are we going to go about implementing this? What's the underlying design we're going to be used, and how's it going to be implemented? And also interfacing with the test team. So the design lead and development lead, really these go together, and I probably should have design / test development. Those folks are going to be the sort of in charge of the technical development, and there's going to be a team under them who are focused on development. Okay? And typically there's a couple people who really, really love development, like to take the bull by its horns and wrestle with putting out code. Just put out good code, please. These should not be code cowboys or code cowgirls who pump out code which is large in number but poor in quality. That will sink the project. These should be folks who really have an aspiration to putting out good, high quality, well documented, well commented, and well tested at a unit level code. There should be a risk officer. Design lead is a full-time position, development and design lead. And they're coordinating that team. They're trying to figure out, okay, who gets to do what sub-job. You know, so-and-so is going to be really busy over the next 2 weeks. We're going to need to do more, you and I, and they'll probably be getting their hands quite dirty with the code. Okay? A risk officer is a part-time position. It could be taken on by someone doing this, although probably not the lead, but someone, a member of that team or a member of the testing team, or someone who maintains the build. And these folks are basically charged with reflecting every week on what risks are out there, has anything changed there, and keeping their ear to the ground and eyes open as to what risks are coming about within the team. So risk officers should always be thinking about what could bite us. If we look forward a month from now, how could we be in hot water? You know, what's coming down the pike? Has this thing been requested yet of the tech staff? Has anyone tested out this technology which we're claiming we're going to be using? I remember a team a variety of years back with N-Hibernate. They said, we're going to use N-Hibernate, and it sounds great, and oh, fantastic. I read all about it online. Ooh, it's great. And they tried to put into place, I think, a deliverable 3 or something, and it all fell apart. And they spent the next 2 deliverables just kind of trying to deal with the fact they couldn't get it to work. They had tested out early on with some small examples. They could have sidestepped that entire issue and realized, okay, this is a lot more complicated than we think. Let's have a plan B instead. Daily build, we're going to be talking about continuous integration. There should be a build master for this. Not a full-time position, but it can take a significant amount of time, and it should not be done off the edge of your desk. It should not be done reluctantly, you know, once every few weeks. This is something which may require your attention daily if the builds are broken, particularly. Putting in place Maven scripts, or depending on the technologies you use, scripts for different platforms for maintaining the build, and integrating it up with technologies like Hudson, Jenkins, Cruise Control, TeamCity, or various other continuous integration servers. So this should be someone who is pretty good with configuration of systems, pretty good with the sort of comfortable with system config stuff, acting as root, installing packages, etc. Testing. I am skeptical of a team that claims to avoid having dedicated testers in this project. Teams have attempted in the past, and they've often done poorly. I'd like to see a team of at least 1 or 2 people, probably at least 2 or 3 people, dedicated to testing. Dedicated to testing. I know that to a lot of you that sounds perhaps unglamorous. Perhaps it sounds like, what could they be doing? Testing all the time. Believe me, there's a huge amount that you could be doing. There's a whole set of technologies that we're going to be discussing in this class that center around making testing more effective. There's algorithms to figure out how to test code most effectively. There's diagrams that you can create. Constructs like dependency matrices involving features in the tests that test them, or particular modules of the program, which tests actually are working on them. There's diagrams like path diagrams, which trace the different broad states of a program and help you reason through, okay, we got to test this path and that path. There's mapping out use cases. There's doing integration testing of multiple components of the system through the use of mocking. We're going to be introducing these technologies. This is just the greatest hits thing that I'm talking about here, but you've got to realize testing is a lot of the formula to success with this project. It's not the only thing, but it's a big component of Q&A, and it will complement the peer reviews that I'll be talking about. So testing side, there should be a test lead. There should be someone that the dev lead could go to and say, okay, you know, let's talk about testing. You know, we've got this code in place, but I'm kind of worried about this module. Can you folks go at her and really test it? And the test team should be giving feedback to the dev folks about there's something wrong here. You know, it's not out-and-out crashing, but it seems that I'm getting weird behavior from this about 1 every 10 times, and pass it over to the development side. So there needs to be really close sort of coordination between these two teams, the testing team and the dev team, okay? And the testing team will have different technologies and will be experts on testing. Yeah?
So, I mean, to a certain extent, we're all used to writing our own tests.
Right.
Our own code.
And that's going on. So great question. The dev team should be doing a lot of testing of what sort? Anyone remember from 214? Assertions. And what sort? Yeah, unit tests. So I actually request in this class that you use TDD. What's that? Test-driven development. You actually write the test before you write the code. Writing the test, or someone else writes the tests and gives them to you. Those tests basically functionally say what elements of the expected functionality are, and very importantly, they help you think through what's needed from your code. I'm not saying all your tests have to be written before you write the code. Far from it. But there should be some tests that you write in anticipation that how are you going to have confidence that your code's working? I mean, after all, if you write your code, you've got to have some confidence it's working. You might as well write those tests early on. So I do request this. And so there's going to be quite a bit of unit testing required. What is the test team going to be working on then? If the unit tests are by and large coming from the dev team, what is the test team going to be working on? What sorts of tests? What other sorts of tests are there besides unit tests?
Integration tests.
Yes, integration tests. So these would be tests that bring together component A, which has been tested in isolation by unit test, component B, each also tested in isolation by unit test, and now testing how they work together. How is that? Help me understand, folks. There's another key technology. How is it that we could do, suppose we have module A, and it depends on B and C. How can we unit test this in isolation? I mean, after all, it depends on these. It calls off to them. How can we test it in isolation? Mocking. We mock these things out, folks. So instead of using a real B, we use a mock version of B. Instead of using a real C, we use a mock version of C. And those mock versions do things like they'll return very simple values, or they'll return random numbers, or they'll return some values read from a database. And these values that they return will let you understand, is A working properly, without having to get all tangled up in whether B and C are working properly. And critically, it'll mean you can test A at a unit level without B and C even having been written yet. You're just interacting with this mocked version of it. More to that, this mocked version, folks, B and C, can actually test the sanity of things that A is requesting it for. For example, A may say, look up this value in the dictionary, and B can say, okay, is that key non-null? We should only be passed something that's non-null to look up in the dictionary. Is this key non-null? And mocking frameworks out there like Mockito or JMock, for example, are popular frameworks for doing mocking in Java code, among other things. And there's adaptations of these for other languages. The beautiful thing is that many of these frameworks allow you to declaratively say what should B expect from A. For example, to declaratively say, A should only call this method of B one time. Or it should always call method foo before method bar. Or it should always call foo with a first argument that's non-null, or something like that. You can declaratively specify that and basically observe if A is working properly. So with unit tests, these are actually mocks of B and C. Now, for integration tests, now we can actually test that A works with B and C in a full-bodied capacity. And that will be very important, because each of them could have been written reasonably, but together they don't work. They have different conventions as to what they expect. One of them is supposed to do something, but it falls to the cracks because neither one did it. Or both of them do the same thing in a duplicated fashion. So integration tests can test that these pieces work together. And then system tests. Okay. System tests are going to, and this is an area that traditionally teams in 371 have failed to deliver on well. Some teams have done it, thing of beauty, but most teams have not done well. What would a system test be? For if you have a system, maybe you have a crowdsourcing platform, and you've got your handheld device, and you've got a database up on the server. What would a system test involve there? It's an end-to-end test often. It's making sure all the pieces of the system for common use cases work together. Does that use case as a whole operate properly? So I go and I enter this thing into my handheld. I go and I say, oh, that's an interesting animal. I go to the animals channel and I take a photo of it and make some comments and upload it. Or I see some mushrooms and I say, okay, I'm going to take some photos of mushrooms from these angles and put it to mushroom channel. And that gets uploaded to the server and uploaded in the database. And a system test would check end to end, okay, did the information get recorded properly all through that use case? So these will often be focused on an entire use case and basically represent a realistic or semi-realistic, at least plausible sort of case in which the system could be used in putting through its paces. Now, what I don't want to hear from you folks is what I've heard from other teams, and that is from some other teams, and that is, well, we can't system test our system because it's a web-based system, because you have to go through this UI. Why is that not a good excuse? Yeah, you should have made it with testing in mind, particularly, folks, the UI code. So here you have this great UI with edit boxes and buttons and sliders and various various up and down controls or what have you. Great, so you have your UI, but when the user interacts with this, for it to do its job, it should be calling off to some other components. By separation of concerns, the code to do the work of the system should not be should not be all tangled up with the UI. If it's tangled up with the UI, testing is indeed very hard. Why? Because you have to frob the UI. You have to get code which pushes buttons and does up, and so on, or you need a person to do it. And neither is very fun. Instead, what you want is a separation of concerns. You want this thing to call off to some middleware layer, some layer of objects, for example, middleware. And by calling off to the middleware layer, it makes things happen. The button is pushed here, and you tell the middleware, do this. It doesn't have to use that voice, but it tells the middleware, accomplish this with these sort of parameters from the UI. And that's what you can drive programmatically in your system tests. Your system tests could put the system through its paces, the same paces the UI would perform. Now, if you couldn't do that, if your code was tangled with this in a most unseemly fashion, well, I'm sorry, but that's really not good. But if it were tangled with this, could you still do system-wide testing? Yes, you could. It would just be a lot more painful. What you would have to use is a system out there, and there are quite a few systems out there. I remember one of the early ones was JRobot. More recently, there's automation platform that comes with is prominent in areas of Java 8 and earlier versions of Java as well. And there's tools that work together like Abbott and Costello that basically go and actually interact with the UI. So they actually do push buttons, and they do interact with this in a way to simulate the user requesting things, etc. Those are more difficult to work with. Why? I encourage you to do that. I encourage you to look into that and to have some code which interacts with your UI, perhaps in a random fashion or what have you. Make sure the error conditions are handled. Why is that more difficult? Why is it What does it get you less far per hour invested to do it that way compared to doing it programmatically? To say, do this, do that. Yeah, the issue is, in a way, yes. So at an abstract level, the specification of the test at the UI level is often more cumbersome. In older frameworks, it was very, very fragile in the sense that you would have to specify the pixel level coordinates where you want it to click, for example. And if someone moved a button in the UI, it would break the test. Now it wouldn't be pressing the button. It would be pressing, off into the panel itself or something like that. And so these frameworks, they have to have a way of sort of saying, okay, what do you interact with in this UI, in this form? And often that's kind of cumbersome, and you have to write these kind of scripts which are rather painful to create and often quite fragile in terms of changes of the UI. So if you were to then take this dialog box and make it part of a wizard, and you have, a next here to go to the next thing, and you split off half of these to go to another dialog next, then you move these over here to this other dialog. Now suddenly you have to rewrite your test, and that's painful. Whereas often at the system level testing, if you're programmatically testing, if you're calling up to the middleware layer, that's evolving less quickly. Ladies and gentlemen, I told many of you this in 214, but I'll tell it to you again. And then at the end of the semester, I'll tell you what I told you. Much of the art of software engineering is anticipating with proactively and getting ahead of change. It's flying ahead of the plane. It's learning to know what things will probably need to be flexible because the client's interested in a change to these areas, or because technology's really evolving quickly in these other areas. We need our system to be able to be nimble in these zones, and often UIs are one of them. Things are just evolving very quickly there. Mobile devices and different standards for web applications, etc. Things are evolving UIs really quickly, whereas middleware layers and database layers are often evolving at a much slower pace. And so, ladies and gentlemen, if you and your system tests can do it with respect to middleware APIs rather than with respect to the UI vagaries, that will be really helpful. Among other things, guess what the user is going to see? Will the user be seeing? Do you think Daniel up here, do you think he'll be seeing the middleware? No, he doesn't care particularly about the middleware as long as he gets the job done. What he sees is the UI. And often the client, therefore, is going to be requesting changes in what they see, which is to the UI. So if you can do testing of the UI, but put more of your effort into programmatic testing at these other levels, you'll be in a better situation than if you have all your system-wide testing going through the UI, because a lot of it will have to be rewritten when the user requests things. Does that make sense to folks? So this UI is often a fast evolving component of the situation. Okay, so let's, I guess I should say, okay, triage team, there was some confusion about this in past years. Triage team is not a permanent, in contrast to these others, it's not a kind of permanent position. It's not a position which remains in place all through the term as, day to day to day. This is a team, it's kind of like a contingency plan. You need to know who you're going to call on when you're getting close to a deadline, and you have to decide as project manager what stays and what goes. We've been working hard on a certain feature. The client really wants the feature, but it's buggy. Are we going to go for it, or are we going to leave it out of this round? Yay or nay? Who's going to be working with me? And often this involves diving into STIs, okay, in the computer science sense, system trouble incidents, databases. Diving into those databases in order to figure out what bugs that have been, or what trouble incidents that have been reported are real. And we're going to be talking about this a lot in terms of the bug sanitization and active bugs as opposed to unsanitized bugs. And bugs that are viewed as worth fixing versus those that are merely sanitized. Here, you're going to often, as the triage team, need to dive into the reported things and say, okay, which of these are really serious? Which of these are showstoppers, if any? And often that involves assigning priorities to them. It involves identifying duplicates or outdated bug reports and throwing them out. So that's the sanitization process and prioritization process the triage team is going to do. And often project manager needs some helpers for this. So as that deadline approaches, they need someone who can help. And I'd say leads there should be communicational positions. They're the folks who, it's, again, not so much an issue of glamour as an issue of functionality. They need to communicate with the project manager. The project manager needs somebody to talk to on the dev side who can basically give them the scoop on what the state of things are. So when they talk to her, she should be able to say, okay, we've got 2/3 of the features required for this particular wave of the project done, but I'm a bit worried about the 2 remaining features because they're proving really tricky to implement or what have you. Similarly, the project manager should be able to go to the testing team and they should be able to tell them, okay, what sort of coverage are we getting on the program? What sort of fraction of the code are we reaching in our tests? And what sort of coverage do those tests have in terms of the features of the system? How many of the broad states of the system are we reaching in terms of its testing, et cetera? So these folks who are taking the leads, don't be attracted to it just because it's glamorous. It's often less so. You should be attracted to it because that will be key to the success on the dev side or the testing side is this communicational role, okay? So any questions about these roles? Yes, Kurt.
How many of them, I mean, I see full-time, but it sounds like a lot of them should be.
Project manager is full-time. Design lead is typically full-time. Testing lead is full-time. And the testers are typically dedicated testers. Typically, that's been the case for developers. We have had some teams where they switch halfway through. Testers become developers and vice versa. But because of the specialized nature of the technologies involved, often it's not a very good strategy to do. Those are the sort of full-time dedicated positions that are required. There should be someone designated as a build master, for example, but it's not, they're going to be doing other tasks as well. They'll just be the person that's the point person for fixing build issues or for extending the build in a smoke pit to handle new functionality.
So the testers then, the full-time testers,
Yeah.
are not going to be doing any development?
No.
They'll be doing testing.
Well, okay, let's be clear about this. They won't be doing development on the main project. What sort of development will they be doing? Will they be doing any development? They'll be doing testing development. They'll develop scripts to test the system. And they'll write test harnesses. Is that a familiar term?
Yes.
Yeah, okay. 214. So a test harness, for those not familiar with it, will be something that will basically, this is a very familiar thing. If you want to test a component of your system, typically what you have to do is you have to have some code that will set up the system so that that can be tested. So it may initialize a bunch of variables, read some data in from a database, what have you, so that then you can call off to that component to be tested and get back the values and test whether they are reasonable or correct or what have you, or log them to a database. So the test harness, its job is to kind of test out this other piece of the system and to do all the setup and teardown work needed to do that. And Kurt, that's a lot of development. And often writing the test scripts for this is a fair bit of development. And writing the system test to put the system through its paces is often a lot of work. And finally, what will the testers be doing? They will be banging on the system. I had a friend who, when I was in high school, he was a tester for a professional software development company. And they called them breakers at the time. Okay, we've got a bunch of breakers here, and they're going to break our system. And ladies and gentlemen, I stand before you, a breaker. There's a famous history of successful testing teams. There was one team in IBM that was known as the Black Team, and they delighted in being able to break code within a minute of being given it or what have you. And they developed this kind of persona of having long mustaches and evil cackles when they were given the code, and they were just amazingly successful breaking code. They also liked making people cry when they broke their code, which is not a good attribute, but yeah, you can be very effective at testing. Yeah.
Are these people who tipped over a mainframe using the tape reel?
That may have been the same team. I'm not sure, though. It's before my time. But testers are often folks who have a mindset that's very different from developers. Developers, when they test their code, they have a sympathetic mindset often. Let's see if it works. Oh, it's working. It's not crashing at least. Do not. Okay, maybe this goes without saying. Do not assume that if your program does not crash, that it is working. That is not the same thing. Okay, it's like step 0 out of 100. But the testers will often be looking at code in a very different way than developers. By having a dedicated team of them focused on that, you will often find bugs you never would have found with the developers. It's just totally outside what they were thinking of in terms of use or in terms of the challenges that might be through. Okay, questions about that? Other questions?
I have one more.
Yeah.
Does the project manager do development?
Typically less so. Typically their coordination. They may go look at the code to see, how the level of quality associated with it, to assess it. But typically they're not doing much in the way of actual coding because they don't have time to code. And if you have a project manager who wants to code, who really, really wants to have a license to code, that's often a problem. I know people who have been like that, and it's often a sign that they won't actually accomplish their project management goals and that their real priorities are elsewhere. And so the best project managers, in my experience, are ones who say, look, my job is to help this team deliver on this, to coordinate things, to make the client happy, to make the project avoid its major risks. They find that an interesting job, and they focus on that. And they're less involved in the coding side. I mean, they're almost not code involved. But they might come to project peer reviews and critique code, but they're the less involved in the nitty-gritty. Okay? Other questions? Okay, that was a key thing. Okay, so let's talk about peer reviews. I mentioned this earlier. Peer reviews are more cost-effective than testing. They easily pay for themselves. In this sense, quality is free. You'll sometimes hear this statement, and it's kind of half true and kind of not. We used to have in my 470 class, 816, we would have a discussion of this, the degree to which it's true, the degree to which it's an oversimplification. But generally speaking, folks, if you have a code base, making it a high-quality code base pays for itself easily. Peer review is more flexible than testing. I want to highlight this for you. I want you folks to do a peer review soon. I want them to be done prior to the first deliverable, prior to the presentation of the plans, the infrastructure plans for your project. I would like to see peer reviews done if possible. And the reason is it doesn't have to wait for executable code. Testing, almost by definition, needs to wait to at least some code to test. Even if it's just A that's written, you can test it. Or to actually run that testing. Whereas peer reviews, to perform a peer review, this can be done in many types of artifacts. What other sorts of artifacts can be done if testing code is not yet written? What could you do a peer review on? Give me 5 examples. The design plan for it, yeah. Use cases, great. Schedule, yeah, good. Risks associated with it, beautiful. Statements of requirements from the user are another very, very important one early. They're often associated with use cases, but they transcend it. A use case might not include so-called non-functional considerations like performance or security aspects, which are not part per se of the use case, but are often specified in addition to this. So you can start peer reviews immediately. You could do it on the plan for the accountable positions in the project. Lots and lots of things. Please think about it. Testing plans. What broad features of the system will we be testing and so on. You can do peer reviews of that. Peer reviews work hand in glove with testing. Okay, so here are some components for projects. And you can see all through this diagram. This is from a great book by Carl Wiegers on peer review that I'd recommend to you folks. I think it's in my office right now. And you could see all these different little posts in here for where peer reviews can take place. Documentation. What happens with documentation? How could documentation need a review? What bad thing could happen to documentation?
If you're not clear or you're vague about certain things, it gets really bad if one person misunderstands what you're trying to get over to them.
Totally, yeah. So the documentation may say something, and the user doesn't understand what that means, really. Very good. Another way documentation can become problematic is what? Particularly over time. Becomes out of date. This is a big issue. By the way, that's one of the issues why having high-quality products with high morale, with low turnover, is such an empowering thing for teams. That's the virtuous cycle that allows teams to operate with low burden of documentation. Because of low turnover, they don't have to worry that all these things have to be written down in case people walk out of the room and are gone. You can write down less stuff, and therefore it's less of a burden and less of a drain on morale, etc. So documentation is important, but you can go somewhat lighter weight on it if you have fewer issues with turnover. Okay, so guidelines for review here. These are key. A peer review, so we talk about these as peer reviews. A peer review is not a review of a peer. It is a review of an artifact that has been created by a peer. The focus on this is on the artifact. It's not what were you thinking when you wrote this and why can't you write better. If it goes that direction, it will not be helpful. You'll lose people from the team. You will have people hiding problems in their code, procrastinating, not wanting to give codes. This is on putting down things, and it's sharing ideas about how this might be able to be improved in the future and how we as a team can make our processes work more effectively to support people in, for example, writing code or writing specs for design or what have you. Typically, you want a smaller review team. And you try to identify but not solve the problems. Solving the problems is often left to a later team, later time. Limiting the meeting typically to no more than 2 hours. And for formal reviews, which I do require for this course, for some reviews, there should be tons of informal reviews. We'll get to that. But for formal reviews, there's typically advanced preparation. The information is sent out at least the previous day so that people can look at it before the review. You want to use the time to talk about the big picture issues rather than more minor issues. So, in terms of the sort of scope of reviews here, if there's one comment I get most in this course, it is, those peer reviews. If only we had done them earlier, it would have made all the difference. Teams procrastinate on them, and then they discover 3/4 of the way through the term, or 5/6 of the way through the term, what a huge help these are. Spreading knowledge around, in terms of finding issues, in terms of spreading style understanding, all sorts of things like that. So do them early, do them often, and I would urge you to just routinely do these on the right-hand side, pair programming. This could involve pair testing. It's great stuff. Or buddy testing. I test your code, you test my code. Peer desk checks, passing each other, sort of things informally. But up here on the left, inspection. And those statistics that I had up here on the slide from IBM were for formal inspections. 3.5 hours per error for inspection removal versus 15 to 25 based on testing. That's human hours of effort required for error removed of testing time versus 3.5 for inspection. So formal inspections are highly effective. And we'll talk about this later in the term, but here's kind of a list of the attributes for these things. You'll notice inspection here requires some planning and preparation ahead of time. There's actually a meeting between the folks. It's not just sent via email. Corrections are made and verification is made, typically, of the results of this peer review. And people have defined roles as part of the planning. They actually come in with different roles that they play within the course of a team. And so here are some of the roles that people take on. And you'll notice with inspection, there's a formal recorder. These aren't all mutually exclusive. People will do several of these. There's a defect checklist that's maintained. There's a leader who's a moderator, and the presenter is not the person who authored it, as would be the case in a walkthrough, but a separate reader who's kind of read through this. The author is there, but they're not actually the one presenting. And that's to try to avoid certain pathologies and make sure that the readers are kind of as up to snuff in terms of familiarity with the code, and the author won't be defensive, etc. This inspection, I do request. I'm not going to engage in orthopraxy about this. I'm not going to be really, really hard on you if you forget one of these things. But this is the best practice standard that's widely used and that is strongly recommended within industry. And these are some less formal components. I really would like to see peer desk checks done, where you informally share documents in pair programming or pair X, pair testing, etc. Okay, so best practices for inspection. I think I'll jump forward on this. See, I have a bunch of slides here, which I'll be posting to the site, the Moodle site, and you can look at this. But I'm going to jump through to another best practice, which is incremental delivery. I think all of you, as part of your 370, those who went through 370 practiced incremental development. You did delivery in several pieces, and there's many reasons for that. One is you can drive it in a risk-sensitive way to investigate those uncertain, to do those things which are most uncertain or which deliver value, the greatest value early on. And this often involves a process of learning, of kind of learning better how things are of what the client needs and where this is going to go. So your conception of where this project will be 3 months from now may be very different at the very beginning versus halfway through after several iterations. And that's because you've learned from the experience of the iteration and the client has learned. Let me share with you some insight that I've acquired after 25 years now of working with clients, often from different fields on various projects. Often it's very hard for a client to really tell you what they want up front. They don't know what's possible. They have trouble conceptualizing what this thing would look like. They have trouble imagining exactly how it's going to work. And it's hard enough for us, knowing all these details about technologies, but not knowing about the domain. And it's hard for them, knowing a lot about the domain, but not really knowing what the technology could bring to bear and how it might be realized. And often, the points at which they really know what they want is after you've shown them 1 or 2 iterations of things. That's when they start saying, oh, you mean you can do that? Well, then maybe what I want is actually this. And that's one of the reasons we engage in incremental development, so that aha on their part does not occur after you've delivered the complete system and now they want to rewrite, but it's when you've delivered some of the most critical value or you're past the most high-risk components. Does that make sense? So getting something concrete in front of people is often the key to knowing what they really want, even if it's very crude. Okay? So I've asked for 5 risk and value-driven deliverables, just stabilizing things early on is part of it, getting the infrastructure in place. Okay, This final component that I'm going to be talking about is daily builds and continuous integration. And really, it's the continuous integration side. So, folks, this has not been a side that I understand to have been emphasized in 370. And perhaps most of you haven't seen this before. But it's a very important lesson that you're going to need to apply when you go into the industry or you go into the external world and work on real-world teams. And that is software development commercially is typically done in a continuous integration context. What do I mean by that? Can anyone tell me what continuous integration means? Yes?
Continuously developing pieces of the software and adding it to the main branch, I would say.
Good. So you're contributing these things over time. Each person is working on it and contributing it. Sometimes as often as a couple times a day. Sometimes a couple days between a big chunk. You're contributing logical chunks at a time, things that kind of work together in a consistent way, so that the system that you, at any one time after a check-in, is stable and is, reasonably consistent and working. But as part of that continuous integration, what is happening when you check something in? Can anyone tell me?
You're running tests.
Yes. So you're running tests. Sometimes you're doing automatic deployment to machines for testing by others. Often you're running stylistic checks. And you are typically making sure that everything builds. If you've got a compiled language, you're making sure that everything builds fine. What do I mean by that? Why wouldn't something build fine? Suppose you've done a check-in. How could that cause a problem for other people? Yes?
Somebody could have committed non-working code with the intention to fix it later, or perhaps it was working for them, but it caused an error.
Yeah, exactly. I mean, so you have your little bit of code, and you say, oh, I'm going to check this in. It's time to go to dinner. I'll just do a check-in. That's not the right way you want to work. Because if you do that, maybe there's some other code in the system which is counting on something in your code which is not yet present. Or maybe it's counting on something you've changed. You've changed the name of a method. They're counting on calling it foo, and you've now called it bar. And when you check your code in, guess what will happen? Now if someone else goes and downloads the system, they won't be able to compile it, right? That other piece of code will be counting on calling foo, and it can't find foo. It can only find bar. And so what you need to do is, when you're working on your code, you need to be working along, and before you check it in, you need to refresh against everyone else's changes. You need to do an SVN update. Is that, yeah? Do an SVN update, or you can do a git pull, and you pull down changes from other people, and you will then be able to compile your code against the latest version of other people's code, which will help identify any cases of things they're counting on in your code which are now broken. And you want to fix those things and run some tests before you check your code base in. So that your code base is working consistently with everyone else's recent changes. And when it's checked in, builds should go on. Deployment scripts are run often, and scripts in order to check style, other features, to run large sets of tests. And one of the most important is this notion of a smoke test, which is a test which is running against the system to basically test sanity of the system as a whole. You haven't broken anything too big, because if you've broken things, other people might not be able to do testing. You've stopped people from being able to log into the system, so they can't even log in, much less get to their areas of the system. So a smoke test is a test that's putting the system through its paces. It's a system test which is designed to demonstrate basic sanity of the system following a check-in. And smoke tests have to evolve, and this is why daily build, or why a build master is so important in many projects to maintain the smoke test. Okay? So that's all we have time to talk about today. I will post this, and you can look at these additional components on here. But I would ask you as soon as possible to look at systems such as Jenkins, Hudson, Team City, Cruise Control, Apache Continuum, which are continuous integration systems. And you might want to look at build systems such as Maven, for example, that will be working together with some of these continuous integration systems to manage the builds for the projects. This sort of component will allow you to work much more effectively on your team projects. Okay? So that's all for today. Yeah, question, Warren.
Are there any more projects going to be pitched, or is what we've got?
So we do have a number of additional project descriptions which are present on the Moodle site, which are associated with various stakeholders. And most of those stakeholders have not been able to come and actually deliver them in person. If there were interest in those,